in the community. Great.
Oops,
Hey, everybody, welcome. So this is the inaugural version of our sort of community AMA session where we showcase folks from our community. In this case, we have Tio, who is our #1 contributor to all of our community channels by far. He is just in every place, answering every question. We're really, really happy to have him here. Hey, Tio, how long have you been using Temporal?
I've been at Temporal for over probably around 3 years now. So
Oh my gosh. Wow. Okay. So you've been around a few blocks, you know a few things. So yeah. But I want to just call out Tio is amazing because he kind of has been in the community channels kind of looking around and being like, there's a lot of chatter right now happening around this topic. I'm going to start a session and see who wants to learn a bit more about that in sort of a more kind of intimate environment where we can do some live Q&A and stuff like that. So the way this session is going to work is I'm going to hand it over to Tio. He's going to get things started. He'll talk for a little bit, and then we'll have time at the end for sort of a live Q&A type of situation. But if you want to, in the meantime, go ahead and add your questions to the chat. We can either answer them as the session is going on or kind of put you on mic at the end of the session if you'd like to talk live. So, and then what we're doing as folks are coming in is just posting to the chat where you're from and how long you've been using Temporal. And we just ask that as you join, please mute the microphone if it hasn't already. And yeah, I think, would you like to go ahead and get started, Tio, or should we give it one more minute?
we can get started. We got a lot of stuff to talk about, and it's recorded too. So,
Right on.
First of all, yeah, thank you, Angie, so much for the great introduction. Everybody, just make sure to say hi to Angie in the community. She's amazing. And yeah, my name is Tio. I've been doing this stuff for quite a couple of years, and of course, we have some other Temporal team members, especially from the SDK team, in this call too. So as far as questions goes, we have a lot of stuff to cover. I always create more slides than I initially thought yeah, I should, but so it's a lot of info, but please feel free to ask any questions in chat. We will have hopefully 5 or 10 minutes at the end for live questions if you would like to ask them. But if for some reason your question doesn't get answered or you think of a question later, feel free to ask it in our Slack. Yeah, we're always there and we're more than happy to help. So one thing I wanted to also add, we have some other community sessions. They're ongoing and we have calendar links for both. So if you want to take a screenshot of this, we do have a design discussion / worker tuning sessions. They're 30 minutes. And we also have the observability, worker, and service metric sessions. And currently I'm doing both of them. You have to sign up, and then the calendar will show, depending on my calendar, when it's available. I know sometimes, because I'm in the Eastern time zone, it doesn't always work for everybody. And I had users DM me, hey, I'm in this and this time zone. Can you make it at a certain time? And we always managed to make it happen. And I don't know if any of you have already been in some of these sessions, and maybe in chat you can share if it was useful for you or not, and for others to maybe feel to join that and take advantage of that. Now this is based on my calendar, so if I'm PTO or something that week, whatever couple of days, it's not going to be available. But anyway, so today we're going to talk about temporal workers. It's kind of like introduction and depth, and it jumps back and forth. But I have received numerous questions about, hey, can you do this? Can you do this publicly? Can you create a session on this? So this is it, and let's see how it goes. Of course, after the session, we really value your feedback. One of these things that's important is we need to know if this is useful for you. And please be vocal in chat. You see the water cooler channel where we have advertised, and also I think Angie in announcements, but let's do it in water cooler channel in Slack. +1, -1, if you want to give some of the things that you want to see in the future about this session, what you thought about it, it would really help us out at the end. So before I forget saying that, I wanted to say that. So anyways, so I thought temporal workers, how to describe them, let's just see what they do. So the first thing is temporal workers receive and apply events from the service, right? What kind of events? Workflow inputs, your client starts workflow execution, your worker has to receive those workflow inputs in order to be starting to run your workflow executions, events like signals, workflow updates, query requests from the client, things like that. And of course, being a distributed system, your workers also receive activity child workflow results, failures, timeouts, and things like that that the service actually pushes to the workers in order to tell your workflow execution, hey, my activity completed, my child workflow failed, things like that. And also, of course, some client cancellation requests that are delivered to your workers and then have to be acted upon. So, of course, workers execute your workflow code in local and regular activity code. Once they have executed this code or some part of your code, that code defines your business logic. Your workflow code defines instructions that you want to perform. So the worker, after runs some of its code, it has to communicate back to the service to tell the service what to do. And these instructions can be, hey, schedule my activity, schedule my child workflow. A worker can also tell the service, hey, I've completed an activity, here its results. Your workflow code could say, hey, create me a timer. Let's say I want to sleep for a day or some duration of time or things like that. Workers themselves have some events that, such for versioning and things like that, that are specific to the workers. The service does not care about, but the worker can still ask the service to add some what we call marker events. These are usually called for versioning and side effects and things like that. Signals, all kinds of stuff. So, the workers can send information to the service, but this information, as far as commands of what the server needs to do, is completely based on your business logic that you're writing yourself for your use cases. Temporal workers do a lot more, so there's a couple of slides on that. They assure business logic determinism, and because workflow executions are not tied to a specific temporal SDK worker, meaning that even if you have a complete outage or some worker failure, your workflow or business core logic can continue on a different machine, on a different worker, basically. But these workers assure that your workflow code still runs in a deterministic fashion, meaning without unexpected side effects or changes during the execution. Workers assure workflow progress. We have something called a deadlock detector, meaning that a workflow assures that there lines of codes in your workflow code execute within some period of time without blocking on non-temporal APIs, right? They produce metrics. Workers serialize and deserialize payloads that they communicate with the service. Of course, workers themselves manage the whole life cycle of local activity executions and their retries, unlike regular activities that the service is managing for the workers. And of course, we have some things called graceful shutdown, as far as if we want to shut down a worker that still might be running some workflows or activities. Workers have some APIs and ways to handle this graceful shutdown, to still allow some of the work that is currently in progress when the shutdown happens to still be performed to completion, if possible. Of course, temporal workers also manage concurrency control, and this concurrency is of concurrent activity executions, local activities, workflow tasks, and other things like, for example, how many activities a single worker can start per some duration of time. So through configurations, and we'll talk a lot about stuff like that, is you can actually manage a lot of things on the worker level. Now, workers also have, and we'll talk about it more, workflow execution cache, where for some performance improvements and reasons, a worker can actually cache a workflow execution in its current state. And then later on, when it needs to be resumed or some event happened that could be days or months later, it can actually resume that execution from its memory rather than having to pull event histories and things like that. So we have also what is the max and distributional workflow activity. Okay, so yeah, so in order to receive basically tasks from the service, Workers are also basically kind of event consumers. So they connect when they start up, we'll talk about that, to the service on a certain endpoint, or what in Temporal we call a task queue. And it says, I want to listen for workflow task or activity task, or both of them, on this particular endpoint, and receive them and then act upon them. What temporal workers don't do, and this is also important, they don't control concurrency of workflow execution. We get this question a lot. People think, like, when we said the concurrency of workflow tasks, so let's say I want 2,000 workflow tasks max for this worker, I can still run a lot more workflow executions on this worker. So we don't control that. And also, the worker does not manage workflow execution lifecycle. No matter what the worker does or tells the service to do, the service itself, that being Temporal Cloud or your on-prem cluster, does make the ultimate decision about any workflow execution lifecycle, such as completing it, terminating it, timing it out, and things like that. Even, of course, starting it from begin with, the workers have nothing to do with that. So the worker sends recommendations or these commands to the service, such as, hey, complete workflow execution. But the service at that point, and in some use cases it does happen, such as this thing called unhandled command, and we'll get that if you want to, can reject their request to complete execution to maybe deliver some more events. So long story short is still the temporal service is the source of truth for managing the life cycle of workflow executions. The workers don't do that. So, but from the code perspective, we said the workers do so many things, but from what you have to write is actually fairly simple. It's a couple of lines of code. You have to create a new worker, you give it its endpoint, such as what we call task queue, and then you have some options, right? In this case, we just show an identity. Identity, you don't have to specify it. It's optional. I think by default it uses like the process ID and the host name, but it makes sense a lot of times to set a unique identity to some worker, because then it becomes easier when you start debugging and troubleshooting in event histories and things like that. Then you register your workflow and activities with this particular worker, telling the worker, hey, you're going to be being able to process and run code for this workflows and my activities, and you basically just start it up. So this can run in a process that you deploy yourself. So I have intermittent slides with some random questions that I thought of. And one question that comes up is fairly easy, but it does still come up quite a bit, is, can a single worker poll on multiple, okay, this is WAS queues, but they should be task queues. I'm sorry for the typo. And the answer is no. A single worker can only poll on a single endpoint on a single task queue. You cannot poll on multiple ones. And that means also it can also only poll on a single namespace, because task queues in Temporal are unique to the namespace. Sorry about the typo too. If you want to have a use case where you need multiple task queues, you will need separate pollers that poll on the other task queues. Yeah. Okay. I think. Okay, can multiple workers poll on same task queue? And the answer for that is yes. And that's also useful for scalability purposes and things like that. Task queues in Temporal can have multiple listeners. So in some cases, you want more than one more worker. And we'll talk about how to scale and what to scale on, and when to make some sort of decisions. But yes, definitely, you can scale out your worker fleet to match the needs of the throughput and performance that you need for your use case. And you have some cases we have when some users and customers have hundreds of worker pods or containers with workers that they're pulling on the same task queue for workflow and activity tasks. But one thing that comes up a lot, also question, if you have a single deployment for your worker, so pod or container process, you should not have more than one worker that pulls on the same task queue. That means don't scale out your workers in the same process, because they will you reuse the same resources for their process or pod or container. Scale out the number of those deployments, unique deployments, because that is possible. Okay, so another question. If I have two workers on different hosts that pull on the same task queue, can I register only activities on one and only workflows on the other? And this is also common questions. people ask, okay, I have one worker that pulls on task queue A, and I'm just going to register workflows with it. And then I have another worker that also pulls on the same task queue A that only has activities registered. And you can't really do that. So all workers that pull on the same task, you should all have same workflows and activities registered. And the reason for that, again, is workflow executions are not tied to a worker, and a single workflow execution can actually move between workers sometimes. And also for activities, each activity execution or its retry, which is also an execution of the activity, can land on a different worker. So if an activity gets dispatched to a worker that doesn't have that activity registered, let's say, in that case, the worker would basically come back and saying, hey, I don't have this activity registered, and then we'll introduce delays. Meaning the workflow task will be dispatched, maybe it gets dispatched to the same worker, same thing happens until it lands on a worker that actually has the particular activity type registered and knows how to process the particular activity task or activity code that it needs to run. Can two workers process same execution at the same time? So the answer is no. Temporal makes sure that cannot happen. Only a single worker, even though multiple workers can pull on the same task, only one can be executing a workflow task for the particular workflow execution at any time. Can a workflow execution switch between different workers? Yes. So we already said that their executions are managed by the service. During a life cycle of a workflow execution, it can get processed by multiple workers. A lot of times you don't see that. You see the same worker identity from the very beginning to the end, but there are some cases where either the worker restarts or we'll talk about cache eviction, so things like that, where a workflow task can actually move between workers. And in that case, it doesn't start and complete on the same worker. How can I tell which worker is processing my workflow execution? The event history can help you with that. If you look at the event history, you can actually expand, let's say in the cloud UI or your web UI on on-prem cluster, your workflow task started events, and you can actually see an identity field there that will give you the identity, if you guys remember in the code, where was that? Here that we set for our workers. And that's kind of helpful sometimes, and this question comes up. So how can I tell which worker is processing my activity currently? Okay, so that's a bit of a separate thing. For completed activities, look at the identity property of the activity task started event. And we'll talk about that, and that's a big misconception that I really want to kind of make sure that we talk about here. Activity task started event doesn't actually get written until the activity completes. And that question also comes up a lot of times in community, also and for cloud customers as well. But for running or currently retrying activities, we do have this information in memory. We call it pending activity information, which does include the identity of the worker that has processed the last attempt or retry of this activity. When you can get that through the UI, or you can call the describe workflow execution API directly. And then another question that sometimes comes up is every activity retry processed by the same worker? And the answer is no. Every retry of the activity is a new execution of this activity. Activities don't have a concept of the sticky task that workflow tasks do. And every retry of this activity can be performed on a different worker. If you have 5 workers and you set max attempts to 5, it could be that each retry is performed on a different worker in this case. All right, so one of the things I wanted to then kind of introduce a little bit is what does the worker do when you actually start it? So in our code we saw previously, once we create our worker, we register activities, and we actually call run on it to start this process, worker process. One of the first things that the worker is going to do is actually call the service, and with this gRPC API called get system info. And the reason why I'm mentioning this, this actually itself becomes pretty handy sometimes for troubleshooting. For example, workers emit a metric called temporal worker start. So the worker itself, when it starts up, it increments this temporal worker start counter, so you can measure that. But from the server side, you can actually look at service request metric for operation get system info. And sometimes this comes handy because sometimes unexpected worker starts could mean something that we want to troubleshoot. Hey, why is my workers restarting? Maybe it could be a restart that's unexpected, and all of a sudden we see a jump of get system info call to the service, and then we can start looking at, hey, what happened with my workers? Did they run into a crash loop, back off, or whatever, or had some issues and restarted themselves in terms of resource utilization, blah, blah, blah. So that comes in handy. Another thing that workers do when they start up, they look at our executor slots. So one part of the workers themselves is the concurrency of activity, task, and workflow task processing. And we control that through configuration. And the workers have two, which you maybe think of thread pools or some sort of pools of go routines. And that defines the max number of workflow tasks or activity tasks this worker can execute concurrently, and we call them executor slots. So one of the things, and another thing that the worker has is what we call pollers. Pollers are connections to the service, and that they are used basically as listeners for task, and the service can dispatch tasks to the worker through the pollers that then are delivered to the executor slots for execution. The first thing that a worker does is it looks how many executor slots I have, let's say, for workflow tasks, and how many pollers for workflow tasks I have defined in my configuration. If the number of executor slots is greater than the number of pollers that I have defined for this workflow type, then start all the pollers. Basically, if our executor slots is 10 and we define 5 workflow task pollers, the worker can start 5 workflow task pollers, meaning the worker cannot start more pollers than he has executor slots, right? So in some cases, so when you do your worker configuration, and we see this a lot, it makes no sense to configure more pollers than task queue executors, than executor slots. So that's kind of like something that may be useful to you. And if, for example, you set activity executor slots to 1, but you set 5 activity pollers, it will still only be 1 poller that gets started because we only have 1 activity task slots to deliver a single activity task at a time to this poller. So does the poller actually poll at some predefined cadence? So some of our users from questions previously think that the workers actually, like, let's say every 10 milliseconds, 1 second, ping the service and see if there is any workflows tasks or activity tasks available. So now these poll workflow task queue and poll activity task queue calls that the worker does through the pollers is a long poll gRPC connection that has a 70-second timeout. So if a poller worker opens up this connection and doesn't receive a task within that timeout period, it would close that connection and then check again its executor slots to see, do I have any more executor slots? Let's say for activity task, yes, then let's recreate the poll connection back to the service to wait for another task to be dispatched to it. So how many pollers should I have in general? Some generic answer is, well, first of all, it's a bit of a thing that comes up sometimes, is at least as many as number of matching service task queue partition. Task queues on the server side in Temporal have partitions. And what we want to do on just core, without looking at like performance or throughput or anything, we want to have at least number of, let's say, workflow activity task pollers that at least match the number of task queue partitions, which is 4 by default. I know some of you guys that are running on-prem clusters, you change that in dynamic config. You change num, read, and write task queue partitions to something else. So if you change it to 20, you should have at least 20 workflow task pollers and 20 activity task pollers to saturate all the partitions. And the reason for that is that a task from history service gets dispatched on a random task queue partition in matching, and we don't want that extra delay of that task possibly not having a poller on the task queue partition assigned and having to be moved to what we call a main task queue partition, and it's a bit of delays. So that's why that recommendation. But typically what I've seen on some normal, not very large, but let's say regular type of workloads, having about 10 to 20% of number of executor slots. So if you have, let's say, 100 task executors for activity task, you're looking at about 10 to 20 probably activity task pollers. But again, that's something you need to measure, and it's very use case dependent as well. But that's kind of on average, well, at least what I've seen. But okay, so we talked a bit about this. What if I define a single activity executor slot? Some of you are running very high CPU, GPU intensive activities, where a single worker can only run one of these activities at a time. So in that case, set also max concurrent activity task pollers to 1 because you only have one executor slot. But in this case, because we have by default 4 task queue partition, consider moving that activity to a separate task queue and reducing the task queue partitions to 1. So you only have one single task queue partition, and you can assure that that poller is always going to be polling on the single task queue partition, and you don't have the extra delays of having to move tasks between task queue partitions until you hit that one where that one single poller is assigned to. Anyways, one of the things that I wanted to also talk about is, especially for workflow tasks, is the task queue kind. So your workers, when they poll for workflow tasks, they're actually polling on 2 workflow task queues. One is, of course, what we call the normal task queue. This is the task queue that every single one of your pollers is going to have pollers assigned to it. But each worker also has what we call a sticky or a worker-specific task queue, and that is responsible to deliver tasks only to it. There's some reasons for that. So if you have, let's say, 10 workflow task pollers in your configuration, your workers will allocate some percent of these workflow task pollers between these 2 task queues, normal and sticky. For core SDKs, there is a special, like a setting called non-sticky to sticky poller ratio configuration that by default is 0.2. And this comes a lot in worker tuning sessions we have with our users and customers, especially if they're running TypeScript. Core SDKs are basically SDKs that are based on our Rust core SDK, so TypeScript, Python, .NET, and all the new ones, basically, they're coming out, and the great SDKs. But this default setting prefers more of long-running executions that burst on updates to existing executions rather than a use case of burst of new workflow starts, right? So oftentimes, when users have a use case where they burst both on workflow starts and have long-running executions that then receive a lot of signals and things like that, changing this to, let's say, a 0.5 and things like that, or adjusting that helps a lot. And that's why I was putting in this slide. The Java and Go SDK, and I'm sure our SDK guys can put more stuff in chat here that I'm not aware of, but they do more of an automatic adjustment of the pollers between the sticky and non-sticky task queue, depending on some latencies that they're measuring at that time, such as work scheduled to start latencies. In this case, sometimes because we have those 2 task queues for use cases where we burst on both normal and sticky task queues, having more workflow task pollers than you need can actually be beneficial in some cases, and we've seen performance smaller latencies introduced by that. Okay, so looking at some metrics, which metrics should I look at for pollers? For the worker metrics, we have temporal long request failure metric. This metric is really important, mostly if you're getting rate limited and RPS limits. If you see temporal long request failure going up, most of the time you also want to check your resource exhausted, because the poll APIs have the lowest priority of a lot of different APIs like start or signal workflow execution. So in 99% of the cases, if you're starting to get rate limited on the request per second, RPS limits on your service, this is going to be the worker metric, because you're going to get rate limited on pollers first. Long request latency, you can check that. Temporal workflow task queue poll empty and success. You can measure if a poll, how many percent of your, let's say, activity task pollers didn't receive an activity task within their timeout, things like that, and also for workflow task. From the server metrics, we have service requests. Service requests basically measures all the operations that come from the outside to the front-end service. And oftentimes it's good to measure poll workflow and task and poll activity task API calls. And even if that goes to 0, you can say, okay, my workers stop polling. Now, always note server metrics are on namespace level. So just make sure you understand that you can get task queue-based information from server metrics in most of the cases, if not all. Okay, so one of the things I wanted to kind of talk about, because a lot of questions come from it, is, and I'm going to have to hurry up, is scheduled to start latencies. So scheduled to start latencies, a lot of people know they're important, but they're kind of like, okay, what the heck is a scheduled to start latency? And the way to kind of describe it is from 2 points of view, from the server view and the worker view. From the server point of view, when the service creates a workflow task and places it on a matching task queue, that's when it's scheduled, right? From the server point of view, the workflow task is started when the service dispatches a workflow task to one of the workflow pollers, if available, right? And from the server side, you can also measure schedule to start latencies via this task schedule to start latency metric. Understand, again, it's on namespace level, and you got to filter it by task type. So another thing that's important is if the service cannot, for some reason, dispatch a task within what we call a sync match, usually it's about 500 milliseconds, we don't want to lose that task and we persist it to the database. So there is also another server metric called persistence request for operation create task that you should also look at, and can also be a measure of backlog as well. But in some cases, when you have under optimized workers, you will see higher rates of this persistence request for operation create task, meaning our matching service has to write a lot of tasks or backlog tasks that we couldn't dispatch sync to our database, and that can put a lot of pressure on the database. So for you, they're self-hosting. That's probably very important at this point, because you want to make sure that you're not putting a lot of burden, extra burden on your database, just because your workers are now optimized as they should be. So what is a good schedule to start latency for workflow tasks measured by the service? It depends. Database is going to play a role. Your SDK workers are going to play a role. But the kind of optimal thing that maybe we should be shooting for is something under 50 milliseconds in this case for both workflow and activity tasks. For activity tasks, it's different if there is some rate limiting going on. If you explicitly have to rate limit activities on their activity task queues, that's another thing. But for workflow tasks, yeah, that's kind of what it usually is. So another question that comes up a lot is, if my workers are completely down, so I have no worker metrics, how can I measure task queue backlog? And that is true. No workers, complete worker outage means no worker metrics. We can't measure workflow task schedule to start latency. So again, you look at the persistence request currently for create tasks, that's going to be help. In the future, we're also adding a backlog hint provided by the described task queue API. Is there a limit of tasks that can be on the task queue? And that question also comes up a lot. How much backlog can I create? Okay, so we said tasks that cannot be dispatched to the worker are actually written to the database. And then when a poller becomes available, matching service will read it from persistence and then dispatch it to your workers. So there is no limit on the matching side, service side, but there is a limit on your database, just letting you know. And if you hit the limit on storage of your database, yeah, so there is a limit. So your database is the limit, basically, in this case. From the worker side, scheduled to start latencies is a task is scheduled, again, when it's scheduled on the task queue on the server side, but the start is a bit different. The workflow task is started when actually the worker receives that. So not from the service point of view when it dispatches it, but the worker measures when it actually receives the start and starts running your workflow or activity code. So we do have the worker metrics, temporal workflow task scheduled to start latency, and for activities, activity scheduled to start latency. Just note that from the worker side of things, the schedule to start latency can be a little bit higher than what the service sees because you have a network in between. And we also have a metric called temporal request long request latency metric that can measure the latency of your pollers. So don't be surprised if the worker sees a bit higher latencies than what you measure on the server side in some cases when there is network latency, but a lot of times they're just the same. Another question that comes up a lot is, can I use event history timestamps as indication for schedule to start latency? A lot of users, they look at the event history, they might not have worker metrics yet, or they don't have the metrics set up yet, and they just look at event timestamps in the UI. And the answer for that is yes for workflow tasks, okay? You can look at the timestamp of workflow task scheduled and workflow task started, and that's going to be the service point of view from when the matching service gets the task and schedules it until it's dispatched to your worker. Yes, you can do that. But for activity task, you cannot. And that goes back to activity task started event being written. It's actually the last retry of the activity after it even completes. And this activity could have retried millions of times in between. So some of the, yeah, we did get some questions. Say I see like a large discrepancies between activity task schedule and started. Why do I have such start? No, look at attempt count, things like that. It's not really something you can do for activities. Anyways, so let's talk a bit about worker task executors. We talked about you can set a limit of concurrent executions of your workflow tasks and activity tasks on a single worker. The metric for that to measure the size or the available task slots, so once they're free up, they still can receive tasks, is temporal worker task slots available, and you filter it by worker type. And that worker type is three things: workflow worker, activity worker, and local activity worker. So if you're running only local activities, not regular activities, this metric becomes very important for you. And this metric itself, I would really write down because it becomes important for scaling, for troubleshooting big issues sometimes even, but it's a very important SDK metric to have on your graphs when you set up your worker metrics. So what happens if all of my activity task slots are occupied on the worker? And I specifically ask you for activity tasks because it's a bit less likely to happen for workflow tasks. Workflow tasks complete within milliseconds. Typically, you just run a couple of lines of your workflow code, which in most cases shouldn't block on anything but temporal APIs. But for activities, that could be long-running activities. So whenever a single worker occupies all of its activity task slots, meaning let's say we define it to 100 and that worker is currently handling 100 activities concurrently, it would stop polling for more work. It makes no sense to pick up any more activity tasks while I am at max concurrent limit of my activity task executions. So that's where this worker task slots available metric becomes key. So if it drops to 0, it can mean two things. Either it's expected, so I am expecting to populate all my activity task slots and it's fine, but it can also mean it's a big issue because it could actually mean my activity is not being released from the task slot, meaning it's not completing. Why it's not completing? It could be blocked on some third-party API. It could be high CPU and the activity just takes longer because the compute becomes slow. It could be some bug in code. I don't know. But this worker task slots available dropping to 0 for any of the worker types can mean I need to scale or I'm having a big issue, right? And that's where we kind of, that's why it's really useful. We didn't talk about worker cache. Worker also, while it's executing workflow tasks and for many different workflow executions possibly, keeps those workflow executions that it's working on, its Go routine or thread, in its in-memory cache. So how large is a single workflow thread or Go routine in memory? That's highly going to depend on what you do in your workflow code. The more stuff you stick in variables, such as you read a 2 meg file or something returned from the activity and store it in a workflow variable, the larger memory footprint this is going to have when the worker caches it in memory. And that is going to be in your heap, right? So the cache size directly correlates to your memory consumption on this worker container and pod and things like that. Now, important thing about workers is that they can evict some executions from this cache, meaning when the cache is full, giving the cache setting that we set on the workers, but we still have to process some tasks for other executions. They're not cached. Yes, we can evict. Workers can evict some of the threads or actually workflow executions from this cache to allow others to make progress. Now, we can never eliminate that because eviction does come at a bit of a price, meaning that whenever a new update comes from that evicted workflow execution, your worker has to replay it, meaning reinstate their workflow thread, basically, or go routine to the state before where it executed last point. That comes with a bit of overhead, meaning the service has to go, worker has to go call this get workflow execution history API, replay, and things like that. So we want to optimize the cache during worker tuning to, let's say, use about 70, 80, I've seen sometimes up to 90 people feel comfortable with. I'm more conservative during worker tuning sessions on your heap size during load testing. But we have to set that cap, and there's always going to be a cap, right? So what metrics should I look out for worker cache? We have temporal sticky cache size. So one of the things that you can actually troubleshoot on is use this sticky cache size is look at your memory consumption on your workers and compare it to the sticky cache size. If they grow kind of together, you kind of have an idea, okay, as my workers caches more executions in its cache, my memory consumption comes up, right? If you see worker cache being low, but my memory keeps going up, okay, that could be my activities consuming a lot of memory. It could be some other library that I'm running alongside my workers on this pod or container is doing that, things like that. So sticky cache size does have its use comparatively to the memory consumption that you're reading from your deployment pods, containers, whatever. Another thing that comes pretty useful sometimes from the server metrics is, again, service requests for operation get workflow execution history. At times, you want to monitor that because let's say you're running at high load and all of a sudden you see a huge jump of the service request for get workflow execution history. Okay, this API can also be called from clients waiting on executions. So if you sync start, if your client starts a workflow execution and waits for its results, then it would also call this. So it could be that, but let's say you don't have, we async, we just say we start the workflow execution, we don't wait for its results on the client. That could possibly mean the worker is doing a lot of replay and a lot of cache evictions because it constantly has to fetch the event history for the workflow executions. And that could at times translate into us understanding we might have to increase our cache size on the workers if we have enough heap size or memory available to have. If not, we might have to scale, right, in order to lessen this load of replaying that just adds a bit of extra latencies for our workers and more work for our workers and latencies of our workflow executions. So what worker metrics should I definitely have on my graph? And that comes up out a lot. Everybody wants to know what metrics. Worker emits millions of metrics. I don't know which ones to put in my graphs. Without having your worker per worker CPU and memory utilization, you can forget about metrics, okay? All of these metrics that you might have may not make any sense unless you know what your CPU and memory utilization is. That is core. And Temporal doesn't provide it for you. The worker doesn't. Well, we'll talk about auto tuning here before the end. But you need to have, like so many times I go into a worker session and people have amazing graphs for worker metrics, server metrics, cloud metrics, but they don't know what their CPU utilization is. Put that on your graph somehow. Make sure that you understand it. For scaling of your workers, you of course have your workflow task and activity scheduled to start latencies. Now, especially we talked about use case specific things. If you rate limit activities either on the worker level as far as how many worker can start per second, or you have a configuration to rate limit the activity task queue, so you tell the service not to dispatch activities or only dispatch them at X number per some time duration, then you can expect higher activity schedule to start latencies, and then you wouldn't care about that, and you wouldn't be part of your decisions to scaling. And then you would really look at worker task slots available metric for activity workers specifically. But those are the three metrics. You have your four things: CPU and memory utilization, and then some combination of this schedule to start latencies and worker task slots available where you want to make your decision on scaling up and down. For troubleshooting, I would always have temporal request failure. For troubleshooting, this is the one metric you cannot miss out on. This will solve you so many issues: workflow task timeouts, activity timeouts, all kinds of stuff. Any sort of request that temporal worker does that's not a pull request, but everything, all the other communications, or respond activity completion, things like that, is recorded in the temporal request failure metric. And that saves so many issues and becomes very handy. And of course, long request failure we talked about for being, let's say, rate limited and things like that. So what metrics should I consider for scaling workers? We talked about make sure you do worker tuning, make sure you set proper executor slot size and cache size to not kill your CPU and memory on your worker pods. And again, you have those three core metrics: scheduled to start latencies and worker task slots available. Any other advice? Let's say anybody asks. Okay, so yeah, don't settle for default SDK worker configurations. Every SDK that we have has a bit different configurations, right? I mean, if you look at, let's say, Java and Go, I would say, Go is a lot. You have like 1,000 executor slots by default. In Java, you have 200 for workflow and activity tasks. Cache size is a lot larger by default in the Go SDK. But every SDK has these default settings, which is perfectly okay. However, I see so many users just go with defaults and start running in their production and don't really care about what those numbers are. And they don't really look at their CPU memory utilization on their worker pods. So they're paying like, Google Cloud or something where they're running their workers on a lot of money, and their workers are like at 2% CPU and memory utilization. That's a waste of your own money, right? So I'm just telling you, try to optimize your workers, if for nothing else, for your cost factor. And even to understand, do I really need that much compute to pay for my workers, for my use case at all, right? So even from the cost perspective, optimizing and tuning your workers makes sense at times, right? So understanding that part. But make sure you load test. Make sure you don't drive your CPU or memory over 100%. Now, we do have a slide. We have a lot of amazing efforts by our SDK team for auto-tuning workers that is amazing to actually prevent this from happening. And that's something that's coming out, and we're getting more and more content about that and more users interested. But it is important right now, even if you're not using that feature, even if you use that feature, in my opinion, still, you need to load test to make sure that you don't go over 100% and start crashing your workers for no reason. Yeah, so that's kind of like some recommendations. Any other advice? Okay, one of the things I wanted to mention is scaling up is great. A lot of users think, okay, what do I use to scale workers? The number of workers, but there is also a scale down factor, right? And be careful when you scale down, okay? And sometimes when you want to scale down your worker or shut down a specific worker, look at its temporal worker task slots available before you make the decision. And the reason for that is we've had use cases where customers or users run very heavy, long-running activities that should not, if possible, retry because they're very expensive on compute, on whatever, it could be the use case. But scaling down or shutting down a worker when that worker is running that activity will be detrimental, meaning that worker no longer can respond with activity completion to the service, and depending on your retry policy, we might have a retry of this activity. And that in some cases can be very expensive. So if you have a similar use case, be careful when you shut down your workers. Make sure that, let's say, if you have let's say 100 activity executor slots and that worker is running 99 currently, so you will have only one task slot available, think about the impact of shutting down the worker at times. Because those activities will time out, because the worker, when it's gone, it cannot talk back to the service and tell it, hey, I've completed all these 99 activities. And then, there's going to be retries. And how expensive is that for your business or not? That's your decision to make, but think about that. That's maybe one kind of piece of advice. Okay, so maybe some of you heard about some worker auto tuning efforts. Yes, look at your SDK release notes on what we're still working on a lot of stuff. We have API docs, but look at your, let's say if you're using particular temporal SDK, go to it on GitHub, look at the release notes. There's usually auto tune session that has a lot of details on that. And some information I got from one of our SDK people to put on this slide as far as the usefulness and how to look at this auto tuning is it can definitely prevent out of memory and over scheduling of things per worker. You can set limits to say, hey, don't go over 80%, but then change my configuration such as task slots available and things like that in order to get me to that 80% that currently without auto tuning you would have to do yourself that we talked about. But still for like cases where you need absolute max throughput on your workers, still consider, self-tuning or configuring your worker configurations. At least that's what I was told to put on there. I don't know all the details. I'm not an expert in this area, but I'm learning myself, and it's really promising. I think this will eliminate a lot of use cases where you have to self-tune, but it's just too complex and just it's a great idea, I think, and something that the SDK team is amazing has done and provided to us. So that's all I had. I think we're almost done. Only 5 minutes for questions. I don't know if there are any questions. I see 41 things in chat. If anybody, go ahead, Angie. If anybody wants to ask a question live or whatever, that's fine.
Yeah, actually, Chad, I was wondering if you wanted to come off mute because you've been a machine in there answering folks' questions, which has been great. For the most part, everything I think got answered or was covered by the material. The one question I saw that did not have a response, which was kind of covered later, so it might be answered, but Raman Gupta, are you still here? If you are and you want to come off mic, you had asked if temporal worker task slots available is the best metric to implement worker auto scaling. And then you just at one slide ago mentioned that we're working on auto scaling. Yeah. So I didn't know, Raman, if you had other follow-up questions from that, if you had anything you wanted to speak live, let us know.
No, I mean, the main thing is when running in Kubernetes, I know that there was some talk of implementing a key to scaler, but I don't think there is one yet. So
I can help with that a little bit. So yeah, as a response to that question, Raman, I put a link to the worker performance page, which mentions some of that. Yes, task slots along with latencies and a couple of other things Tiho mentioned are the main things to look at to scale. We actually have sneak preview, but I won't give too many details for another week or so. We actually have more accurate task queue information that will be able to be requested on demand, which is meant to drive a Kata scaler. We're not at building a Kata scaler yet, though it's partially on our roadmap, but this would be able to drive your own Kata scaler because you'll actually be able to see your backlog, which really should sit at 0 all the time if you can, but not always. Cool, thanks.
Awesome. The other person who asked a bunch of questions was Harsh Chuan. I really apologize if I'm butchering your name. You had asked several questions around whether or not it's possible in Go to process multiple workers in different queues. If you're still on and you have any follow-up questions, please feel free to unmute.
Thanks for giving me the opportunity, but I think all my questions got answered. The follow-up also was great. That was kind of also my thought. What is it that we should monitor when we start running too many workers within one Go process to kind of decide, where the limit is? But I think that got kind of covered in the response.
Great.
Yeah, like Tiho mentioned, the shape of everybody's workflows and activities are different, and different SDKs have different resource levels. You know, some languages are slower or eat more memory or whatever. So like Tiho mentioned, you really got to benchmark these things to see what the upper bounds of your code is.
Very good.
If I may just add one thing. There are very often cases where you might want to optimize your workflow for, I don't know, for example, for very quick starts. You know, you want the first two workflow tasks to be very fast because you have to give back an answer to the API call that triggered that workflow. But the rest can wait. And I mean, there are different, different settings that might optimize for aggressive start or quick execution overall. That's all part of what you have to tune based on your specific use case.
Very good. The last person who asked a bunch of questions was Raymond G, and you were asking questions around the different SDKs and different stuff like that. If you have any other follow-up questions, if you want to unmute and go ahead and ask them.
Oh yeah, thank you. I think Chad answered all my questions really well. Thanks for that.
But thank you all guys for being here. Yeah, thanks for joining. I know we didn't advertise this too long, but please follow up on Slack in the water cooler channel. We would really like to know your feedback on this and your thoughts, especially if you want to see this more often, and if so, what kind of topics you might want to hear about and things like that. It would really be helpful because that feedback is really valuable for us.
Yeah. And I just posted a message to the water cooler channel, so you can +1, -1 if you enjoyed, did not enjoy. We love your earnest and honest feedback. If you're not comfortable sharing it publicly, you can also DM me and I will summarize stuff and get it back to Tio. But Tio, thank you so much. That was an amazing session. Thank you to Chad and James and others who kind of pitched in with helping answer questions. And we'll see you at the next one. Thanks, everyone.